Hello again. Welcome to the second where we look at how to plan for effective teaching in mathematics. Um, in the first half, we looked at different abilities and achievement, and this second part, we're looking at different motivations in mathematics. Now, this is a very broad because they're fun and interesting. Often we assume that maths is boring, where some parts of it, at least, if not all of it, students might find interesting and engaging. So looking for patterns in things, if you're looking for symmetry, if you're teaching about symmetry, there's lots of symmetry all around us in nature that you could look at. Measurement's an obviously practical one. Various things. Some things like money, which are useful and used every day, still might not be that interesting, but there might be some motivation to learn about it if there's some intrinsic value in learning this content. Maybe it's useful for them in some ways. So the list there is not exhaustive in any way, just some ideas. But the critical part about motivation is really connecting to students and their life worlds in school and outside of school. So it's not like developing competence is separate from motivation. They go hand in hand. Kids who are competent and achieving well and understanding stuff are more likely to be motivated. But also kids who are motivated are more likely to understand things and persevere on tasks and then develop confidence and ability. So thinking of these things as integrated rather than separate is useful. And so if you can keep in mind some of the things we talked about in the first half, those things will go hand in hand with these things. But again, this is not an exhaustive list, but some things that come from the pedagogy you use which will help students stay motivated. If you can use visual models, if they can see something, often that is helpful for them. So rather than just talking to them, rather than just giving them something like this where you just see a talking head and some notes on the board, maybe a visual diagram would help, maybe some physical model that they could manipulate and use helps them get engaged. The more of their sensory perceptions you can involve usually helps them to engage and be more motivated. Also, the challenge is trying to keep a balance between giving them challenge, but also the challenge is not so difficult that they fail all the time. So if they're always finding stuff easy, that tends to be demotivating. But also if they are always finding everything too hard, that's also demotivating. So finding a way to scaffold your pedagogy and your challenge with the students so that they find a good balance between challenge and struggling for success or to understand. And that's a real tricky art for you as a teacher. Again, we can't give you any recipe about this because it'll depend on the kids in your class. And as a teacher, as you work in your class, you'll know your students and you'll know that some of them at any given time on any given task might need a challenge, whereas others might need a bit of support because they're starting to lose interest because they're really struggling and they think it's beyond them. That's the art of teaching and something you'll become very good at and you'll almost end up doing without thinking about it as you interact with the students as they engage in tasks. So this is just an example. And again, some of you look at this and go, well, this isn't very motivating. And it may not be. It just depends on the students. But you could take a task like this, or in fact any task you might see in a textbook or online or in a range of resource books or other areas you can get ideas from, and then you modify it to suit your kids. But this is a Year 6 lesson. The content is that we want the students to draw a circle graph or a pie graph to represent the following information and to present it to the class. And this one's about the weather. And again, if the weather's not interesting and motivating for your students, then choose something else. I'm sure you can always find some context that would be interesting and relevant to them. And often your interest and your seemingly noticing the relevance of it will be motivating for them. They can catch it off you. And as we go through here, I'm just going to give you some responses from two students. Alex is what we'd normally consider a high achieving student, but one who likes to work by himself. And when he's in group work, he's this kid that dominates the group because he thinks he knows more than everyone else. And sometimes his mathematical content knowledge would be stronger. And then another student, Jeff, we'll call him Jeff, a low achieving student who said, nobody likes doing maths less than me. So he's a number of learning difficulties in literacy and numeracy. So how would they respond to this sort of task? And how could you could then think about how you could respond as a teacher. What would you do? So there's the solution they've come up with. They drew a table and then they've made this pie graph here, or some people call it a circle graph. I don't mind which one you want to call it. And then they were asked to explain what they did. So Jeff said, we took a circle and divided it up into 6 equal parts. And you can see that that's conceptually incorrect. And then here's Alex's response. We did this so each part of the circle would equal 10 days. Then we tried to estimate how many days would be rainy, cloudy and windy, etc. And then we drew the table from the information in the table and estimated what section would represent sunny, rainy, dull and cloudy. So you can see that his reasoning is much deeper, but you can also see there's some conceptual things you could work on there. But they've both been asked to give an explanation of what they did. So then, what could you do to try and prompt them to think more deeply about it? And these questions will depend again on the student. Would you ask all these questions to both students, or would you ask different questions to Jeff and to Alex? How would you phrase them? Where would you offer some support? So you could ask questions like, why did you make each section of your circle worth 10 days instead of 1 day? Why did you choose lots of 10? Why didn't you choose another method for drawing the graph? How did you check it? How many degrees are in each of the sections of your graph? And why did you estimate rather than make an accurate graph? So there's questions. Some of them you would only ask to Jeff, and some of them you might only ask to Alex. But you see what it is trying to prompt them to think and engage in it more. And while we're talking about motivation, you just need to, in the next slide, we'll look at their responses and see how you respond. It's not just about trying to get them to think more deeply mathematically, trying to get them to reason, but also to take into account their motivation, how they feel about it, their confidence and those sorts of things. When would you press and when would you pull back a little bit? So when they were making sense of their responses to the questions, Alex said things like, because I did it in a group, remember, Jeff does not know how many degrees are in a circle, and he does not know how to draw a circle graph. So we made each section of the graph worth 10 days. And then we estimated and looked back. So how do you make sense of that? What would you respond to a student who said that? These are responses or paraphrases of responses that real students have made. Alex also said it was easier to have us break it into the circle up into 6 sections. The whole graph is worth 60 days, so we decided that it was easier. So you can see his responses are, there's some rationale behind it and some reasoning. So how would you press further on those things? Whereas Jeff said, that's the best I could do. And again, this is a pretty common sort of response from some kids. I did all I could. This is the best I could do. So how would you respond to that? How would you try and motivate Jeff to keep engaging in the material? Clearly he's not up for a challenge per se, but he needs some sort of support to look at things in a different way. Alex said, both of us can understand this way of doing the graph. Jeff said, I don't know, I just know that the 6 goes into 60 days and we drew the 6 sections. So you can see their responses there and how they answered the questions that were on the previous slide. And your challenge as a teacher is you hear these responses and then you have to respond with the next thing. What's the next prompt or question you're going to ask? Are you going to offer some support? And the thing is, you can plan the task, the initial task we did, you can even plan those initial questions you do, but now you can't plan it. You've got to ask these questions off the top of your head while the kid's there. Okay, so when Jeff says, this is the best I could do, you can't say, oh, just sit there for a minute, Jeff, I'm going to go away and have a think about what I might ask you next. You have to say something to him straight away. And what you say can be really critical in terms of motivating them to engage more deeply and further, and how you respond to Jeff and how you respond to Alex might be different. In fact, it will be different. But you have to know your stuff well enough that you can respond in a deeper, meaningful way that helps push them towards greater understanding and achievement and motivates them to keep moving at the same time. These things are not separate. It's a really challenging job, and that's why through this course we've spent a lot of time more working on you and trying to help you think about you as a teacher rather than telling you here's the recipe how to do it. Because although you can plan the tasks, a lot of the teaching you do afterwards is stuff you're going to have to do on the fly. So what's your role in motivating students? Well, one of the key things is just trying to help kids to think of themselves as capable of engaging in it and doing it and making sense of it. That means lots of encouragement. If the kids do something, say that was great, fantastic, I liked your mathematics, but don't just not just a throwaway line that has no substance to it. You want to say something you liked about it. I liked your thinking there, especially the way you decided to divide the circle up in a certain way, or something like that. Try and be specific. The point is, as a teacher, you should be able to find something positive in every student's response. And then providing that motivation, a lot of it comes through encouragement, so the students actually see themselves as capable. Now, another way of doing that is having students do tasks which they think are difficult, but they can achieve it. So I remember one time we were doing algebra with some kids, and as soon as we said algebra, they said, oh no, I can't do algebra. So we didn't call it algebra. We said we just looked at some patterns, we did these patterns questions, we solved these patterns questions, they extended the problems and they did it. And these kids were in year 6. And then when they finished, I said to them, well, by the way, you guys, what you've done is algebra. And they'll go, oh no, we can't do algebra. I said, yeah, well, you've already done it. And by the way, I got these questions out of the Year 9 textbook, and I'd show them a Year 9 textbook where I got the questions from. Now the point really here is not that you want to push primary school students up to doing further mathematics. But the point was these kids all of a sudden thought, oh wow, I'm doing Year 9 maths. It didn't matter that I'd chosen some of the easiest ones out of the Year 9 book. But it was about dealing with their motivation and their sense of themselves as able to do mathematics and engage in mathematics. And by doing algebra, it was the one that they thought was the hardest. So trying to get them to have meaningful success that they perceive as being really important on something they might think is difficult can really puff up their motivation. Another way is through assessment. If you use assessment mostly to encourage kids, then when kids get good results, all of a sudden they're more positive about doing stuff. Whereas if kids fail, it reinforces to them that they're no good and they just give up. So motivation, assessment is not just about finding out what they know, it's about helping motivate kids. And if you've got some kids who are struggling, what I would often do is give them a really easy test so they all get a good mark. Also having a sense of classroom talk that is always about helping students, making sense of mathematics, that they're always understanding it, it's linking it to the things they know and the things of mathematics that we've already covered. Talking in positive ways makes a huge difference. But that talk has to be not just blind, oh, you're awesome, or that's great. It has to be about something specific. Particularly in mathematics, where you'll get often kids even by grade 4, who think they're no good at maths. Dealing with difference, again, this is something that's dealt with in the ACARA curriculums. As you know, the version 9 of the maths curriculum's been released. It probably won't be rolled out and actually active in schools for a little while yet. But in all the ACARA documents, they talk about having students feeling confident and that you have to plan and deal with difference. So in maths, that means you can't just teach straight down the middle of the class. You've got to cater for a whole range of abilities. And it's reasonably well accepted that in any class, the top 10% of the students can be up to 5 years ahead of the bottom 10% of the students. So you'll have some kids who are miles ahead and some kids who are struggling there, and your job really is to make sure that kids that are ahead are still engaged and interested without continuing to push them further and further up the curriculum. And the ones who are behind, your job is to make sure they catch up. So by the time they finish with you, they're at least at year level. So planning and managing for difference is one of the biggest challenges you'll have. And in the past in maths, we tend just to teach straight down the middle, which bores the ones who already understand it to death because they can already do it, they get bored, and the kids who are struggling are further disenfranchised because they can't do it again. So how do you cope with this? The answer is not streaming, because even in a stream class there's a big difference. The answer is the same as you do in any other class really, having differentiated tasks and activities which have different entry points and exit points for students to engage and learn the material at the same time. So the challenge, you've got to provide interesting tasks first of all. And then you as a teacher, as we talked about previously, need to provide prompts and other support and questions that allow students to engage with the task. And you have to do this largely as you're wandering around the classroom, engaging with kids, and off the top of your head, in the moment when a student says something, you have to respond in a way. And if that kid's one of the kids who's quite sharp already, then maybe you're going to offer them a challenge to think about, something that challenges their thinking and makes them look at it in a different way. If they're a kid who's struggling a bit, maybe you're going to say, look, I really like what you've done, you're on the right track. Next time, maybe the next step, just think about this little thing. You can't plan all this stuff in advance, you've got to do it as you're going around. And again, this is why it's important that you are great teachers. Having a good plan is okay, but a lot of the teaching you're going to do is not going to be off your plan. And then you just got to have resources ready in your planning for kids who finish quickly, for kids who are struggling. How can you help them catch up, those sorts of things. So here's some key principles for effective teaching of mathematics. This isn't rocket science, and you've probably talked about these, we've talked about them in your maths courses before, not as a set, but in different places, but even in general things. The first principle is really just let the kids know what you're learning or the goals are for the lesson and the unit and even their whole year if you like. What's your goal? So they know where they're heading. The second principle is making connections. So one of the problems we have in maths is that students see maths as all these isolated little things that have got nothing to do with each other and nothing to do with their real life or their life outside of school. So making connections within maths, with other subject areas, and with their lives beyond school is important for motivation. We've already talked about engagement, but fostering engagement is really important, and you do that by connecting to things the kids are interested in, amongst other things. If you want to know more about that, go back to the lecture we did a few weeks back. The fourth principle is differentiating challenges, and what we mean by this is when you give kids a task to do, let's say you're having a task the kids are going to work on for the lesson, that task should be accessible to all the students in the class at the start. They should all be able to begin in some ways. But once they start on it, they might work on it in different ways. Some kids might need to work through it quite slowly and methodically in more fundamental and basic mathematically ways. Some kids might be able to rip through it quite quickly, and you need to have things that can extend them. So with any challenge and task you've got, they should all be able to start at the same time on the same task. But as they're going through, some kids might need a little just to keep plugging away in that task with some support. Some kids might need some extension sideways without pushing them forwards, and some might need some challenges to push them to think further and differently. In saying that, I would try and avoid pushing them to the content of the next year level. I think there's enough challenge you can find within their year level and doing things to enrich their understanding rather than just saying, oh, you're in grade 4 and you're doing grade 7. Because then what happens when they get to grade 5, then they have to do year 8 and it becomes a mess. So trying to challenge them within their year level is really important. But differentiating challenges and tasks and learning in class will be part of your planning, but then something you'll have to make decisions on as you're going around and working with the students in your class. So that relates to Principle 5, structuring your lessons. We'll talk a little bit about this, particularly relative to memory in the next video, but structuring your lessons so they're differentiated but cater for all the kids in your class, not just going straight down the middle. And the last thing is you want to promote fluency and transfer. By fluency, what we mean is if kids learn a skill or something, that they can do it in an automatic sort of way. And they don't have to give it a lot of cognitive labour. When they start, they'll have to think about it a lot, but as they move along, they want to become more fluent. And transfer just means they see that the things they learned, so they're learning about number, for example, that stuff they learn can be used in other places. They can transfer that learning to help them do other things. So, trying to pull it together. To motivate students, your teaching should invite students to explain what they understand and explain what they've done, why they've done it. And again, you can see this relates to some of the things we've done previously, even things like the Newman's error analysis and things like that. The second part is develop a ZPD. Now ZPD just means zone of proximal development. Again, I'm sure this is something you've probably heard about a lot in your general education courses, but it means having a challenge that's within their zone of proximal development. It's close enough that they can achieve that challenge or that new learning or something, but not so far out that it seems too far away. So if they're already here, it's close enough, but just a little bit beyond them to stretch them, but not so far of a stretch that it breaks and they can't keep doing it. So posing similar and simpler tasks that students can overcome, helping them make explicit suggestions or correcting an error and a misconception to help them move on, recommending ways of proceeding, but trying always to get them to do the thinking. ZPD is quite a complex thing, and that's only a few brief notes. I figured you've already heard a lot about that before. So, when you're teaching maths, what's the attention in pedagogy? What's the purpose of you being there? Well, the students through your teaching should receive explicit messages about why they're at school, why they're learning maths, what's the point of learning maths, and how they can see themselves as learners of maths. Unfortunately, one of the biggest things students learn at school is that they are not learners of maths and they're not capable of maths. And they learn it in our classes. So you need to be really strong in your overt way you teach students that they are learners of maths and they can do it. And as teachers, we need to remember that schools exist for students. That's why we have schools. If there's no students, we don't need a school. But teachers, i.e. you are the critical ones that make a difference. We know from a lot of research that the people who make the biggest difference in students' learning are not principals, or not ministers of education in government departments, are not ACARA, not even people like me or working here. It's you as the teacher in the classroom, because you are the one where the curriculum meets the students. You're the one who manages and facilitates that interaction. And if it breaks down there, then the rest of it's not worth anything. So you have a really important role, a crucial role, the crucial role in education. And that's why through this course particularly, we haven't given you a lot of recipes about how to do stuff, but we've tried to get you to think and reflect on yourself as the teacher. What would you do? How can you think about things? Because there is no recipe about how to do it. But we're confident if you can really think about these things, think about the students in front of you, think deeply about mathematics, then you'll be great teachers of mathematics in schools. And so that's why we've tried to challenge you with all these ideas. I hope that's helpful. All the best.